from an old National Geographic. Now what this shows is all the pollution from North America, highly dense around the Great Lakes, from Detroit to Atlanta, all the way up through Boston. High density of pollution, other pollution around it. This is the current that it takes blowing around the earth. Okay, so see here, it's going to blow over into England. It's going to circle around the pole. See that up there? So it's going to come right back around. Now what we were doing for the longest times was right here in Ohio, my old hometown, Cincinnati kid here, all the coal burning was putting the sulfur up in the air, the sulfur dioxide, the trioxide, the sulfuric acid, and where it would land is in Canada. Okay, nitrogen oxides form nitric acid. So you got these acids literally coming out of the sky thousands of miles from where they were created. So for years Canada was complaining about it and the United States just played dumb. Well, I heard the acid rain was so thick in Sweden, Switzerland, somewhere over in Europe, ladies' nylons would dissolve in the rain because there was so much acid rain. Okay, so this is just giving you an idea how the air currents flows. There's a thing called the jet stream that always runs down and up around 250 miles against the turn of the earth. Remember, the earth is turning this way? Well, look, the air is going against the turn. I mean, this is something they never explained to me. When the kids are learning about planets and they're looking at Jupiter, you know, you see, oh, these storms are blowing in there. We got a 250 mile an hour wind blowing right there. You know where the windiest place on Earth is? This is why, was it Eddie Bauer or Bean, one of them guys? Mount Washington. I think it's up there in Maine or New Hampshire somewhere. Because of the jet stream. Windiest place on Earth is right there up in North America, kind of on the coast, because the way that jet stream comes down, up and around, 250 mile an hour winds are hitting Mount Washington there. So Bean or one of them guys, that's where they test all their mountain climbing stuff. I think it's Bean, not Eddie Bauer. One of those two, though. So this is the Earth, dynamics of the Earth. Now what happens with pollution here? This is what our topic of discussion is today. We've got in the lower regions up to 1 kilometer here is where the auto exhausts and the factories and all this, 1 kilometer, you know, roughly, call it a mile, okay? So a mile up, all these particulate matters and things are in the air. Then they're rising because they're high energy. Usually when you're burning stuff, it's got heat. So it's going up. The rain washes it down. So it's trying to fight its way up. The rain washes it down. Well, then what happens when the rain blows by? There it is, up into the upper levels of the atmosphere. This is where, remember we were talking about the energy coming into the earth from the sun. It's higher energy up here. So the energy hitting your pollutants up there is causing these chemical reactions to happen. So it's not the same as being down there on the surface of the earth where your car is. This is like being up there above the clouds where the planes are. So the big thing about the Concorde is the Concorde's flying way up high there. That's where all the exhaust is coming out. So the reason it can fly so fast is it gets way up there where there's less resistance because the atmosphere is thinner. Well, the pollutants are going right into that higher part of the atmosphere where they do the most damage. Now this, I got to admit, I've talked to some Berkeley chemists and they get pretty vehement about their discussion of the ozone hole. The ozone hole, I believe, is related to the ionosphere. It's the way that the Earth is moving, the charges, how much radiation is coming from the sun, and the hole is over the southern hemisphere. So this may have something to do with, I think, that the land, Antarctica, is there. In the ocean up there, remember I said all those particles that are hitting the Van Allen radiation belt are redirected to our poles if they're not blown out into the plasma sheet. So when they come into the Earth in the poles, I think you got the protons coming one side, electrons on the other. Well, this is where the ozone is a real thin layer, way high up there. So the ozone is what's getting what they call depleted. So this was in 1986. This was about the heyday of the argument. So we didn't really have anything to compare it to. We didn't know what the quantities were. It's time of year that things go different, the seasons of it. So here we are roughly in, is it going to focus, 1982 was the size of it, 1983, 1984, I guess you can see the darker blues getting bigger, 1985, and now look at the deep, see there's not even a deep purple on those early years. It's like no purple or blue. Now you get light blue. Well, now look in 86, the deep purple. So all within the scanning time of 5 years, this is what they observed. The ozone was really depleted at the South Pole. Okay, so this, I guess, is the outline of Antarctic. So what they would be concerned about, I guess, is like this here. What do you got? Green, yellow. So yellow's about the border. Brown ain't bad. Where, this is South America, Antarctic. Where, I'm looking for Australia. So see Australia here, they're showing it in the blue on the sides here. So the ozone is really getting depleted. So some people believe the chlorofluorocarbons are creating that. Others have their doubts. Now this I want to just show is that when you've got to understand what the weather is like. This is the Gulf of Mexico. Here's Florida. Some maps never show. Look how big Cuba is. All our maps make Cuba look like it's real tiny. Cuba's huge. It looks bigger than Florida. So here's a storm. This was in 2004. This was Ivan. And right behind Ivan was little Charlie. Behind Charlie was Jeannie. I remember Jeannie. And then Francis. So look at these hurricanes. 4 of them right in a row. All behind each other coming into the Gulf. So this was 2004. Here it says hurricanes slam into Florida, one after another, in this composite satellite image of storm tracks of August through September. 2 of the most active months of Atlantic cyclones on record. So these were actually overlaid. So this was September. This one was August. That was September. And that was August. So you kind of had this one, and then the next week came that one, and then 2 weeks later came that one, and then Ivan. But here's Florida, so it was catching Florida was the deal. So we're always going to have Mother Nature to contend with here. So see the air. This is what the air looks like. Very delicate, fragile. You seen the shell of a hard-boiled egg? Well, this is the thin membrane underneath the hard shell on the outside of the egg. Did you ever pick some of that apart? That is what the Earth's atmosphere is like. We need to protect it. Now we're going to talk about the pollutants. This was a good little model here from National Geographic I picked out from 25 years ago. So obviously nobody is paying attention anymore to this. So we'll just go through here and show some of the pollutants. Arsenic, that's a metal. Carbon monoxide, nitrogen oxide. Now you've got mercury, cadmium, those are heavy metals again. So all 3 of those, arsenic, mercury, cadmium, heavy metals. These are our atmospheric ones. Actually, nitrogen could be included in the heavy metal. Atmospheric molecules, these are the ones we're going to make in a minute here. Carbon monoxide, nitrogen oxide, sulfur dioxide. Silicon 4 is tetrafluoride. H2S is considered a pollutant. Hydrogen sulfide, rotten egg smell. HCHO, this is why we're going to make the molecules. This, I believe, is formaldehyde. Cl2, chlorine gas. So what are these called? CH